Hi everyone, in this video we're going to be going through the Part 4 group work that we didn't quite get to in class on Tuesday. So this is all coming from the book. So let me put that up. So this is number 3 in the book. So we're just going to go through and do this problem. We're going to take this data, which I've put in a nicer format in the weekly activity for you to copy and paste. So you're going to take this, you're going to find the mean, median, and mode, talk about outliers, calculate those three things again without the CEO's salary in there. So we're going to take out this number, and then we're going to talk about what this means in general. So let's get to it. So I'm going to take this list of numbers. This is my data. These are salaries from some made-up company. And I'm going to go to the Descriptive Statistics app. We're going to clear this out. We're going to paste our data in. Okay, here is our data. 10 numbers. We're going to hit Use Data. Okay, and then when I first go to this, these are going to be unclicked. It's just going to look like this, or unchecked. And so when I want the mean, all I got to hit is this button. Median, this button. I'm not actually asking you for the standard deviation in this, but we'll just do it anyway. And then all you got to do is scroll over, and there they are. Mean, median, standard deviation, and a nice little picture for us. So let's put this information in. Okay, so the mean, if we scroll over here, the mean here is, what do we get? $74,582. That's the average salary if we use the mean. But if we want to use the median, it's $41,900. Quite different than the mean. And the mode, we're not really going to use much, but just so you've seen them. The mode is the most common number, which is 42,000 here. Okay. And we'll write the standard deviation, why not? It's this gigantic number here. Very, very big standard deviation, because even though most of the numbers are pretty close, there's this one number that's very big and very far away. So then part B, what we're going to do, actually, part B is asking for an outlier. So what's an outlier? So what you have to think about this is an outlier is a data point that doesn't really fit the pattern of data points you have. So first things first, you need to have some kind of clumping of data points where there's similarities there, a pattern. With just one variable, the pattern really just means all the data points should be close together. So we've got some data points that seem close together here, and then we've got this one data point that seems very far away. Now, this is a visual way to see that. So this one right here looks like it's an outlier. But you can also just go to the numbers. You just ask yourself, and this may not have an answer, right? But in this case, there is a number. Ask yourself, which of these is not like the other? And you just go down the list. Low 40s, high 30, low 40, low 40, low 40, high 30, low 40, low 40, low 40, and then almost 10 times bigger than any other number, 375,000. This is much bigger than the others, and you can see here, again, much bigger, way off to the side. So our outlier, then, is the CEO salary of $375,000. Right? So it's an outlier because it does not fit in with the rest of the salaries, which are all much lower. Okay, so part C, the directions say, take that out, recalculate. So all we have to do for something like that is take this, delete it, hit Use Data. You'll see my sample size dropped 1 because I just took a piece of data out. And here are my numbers. So let's type these in. My mean now is 41,202, and we'll round to 22 cents. My median, 41,800. Standard deviation now is much lower, 1,328. And we'll round to 3 cents. So looking at this, we see some serious difference. Taking out the outlier had a drastic change on the mean. Check these means out. 74,000 down to 41,000. The median, though, not much change. Didn't seem like the median really cared very much about this CEO's outlier salary. Didn't seem like it mattered. Standard deviation, huge change. That clearly cared about that salary being so much bigger. So what does D then ask? Just go back to the document in case we forget. In general, if there is a very high outlier in a data set, what is the effect, right here, of that on the things we've just calculated? So let's start with the mean. A large outlier, large being bigger in this case, what's it going to do? Well, when we had it in, the mean was much bigger. When we took it out, the mean really shrunk down. A large outlier will have a big impact on the mean. Specifically, in this case and in any other like this, it will make the mean grow. So to be specific, a large outlier, a much bigger number like this salary that we had, right? So the salary we had with the 375,000 inside here, this is going to have a big impact on the mean. It's going to pull the mean up. So you can kind of almost see that here. The red arrow is the mean. The median is blue. See how the blue is pretty close, like almost right on the money with these dots in the pattern. But the red one is pulled over to the right. The red arrow is pulled to the right. So a big outlier, bigger, as in larger, is going to pull the mean to the right. It works the same way with a really small outlier. It'll pull the mean to the left. But in any case, it has a large impact. Okay? I mean, on the other hand, though, outliers seem to have little impact on the median. The median didn't really change. Look, here, changed by $100. Okay, so a large outlier, the median doesn't really care about it. All the median's doing is saying, go find me the middle number in order of the numbers. It doesn't care if your biggest number is 375,000 or 10 million. It doesn't care. It just sees that as, okay, that's the biggest number, so clearly I'm not going to pick that one. I need to go into the middle. So watch what happens. If you want to see this, see this kind of out a little bit more, watch what we do here. So again, I'm going to just make sure I've used it, use data. Here's my median, 41,900. That's my middle of all the numbers in order. Watch what happens if I change this to 75,000. So put your eyes here on the median. I've drastically changed the biggest number, and doesn't matter. Median doesn't care. So I just changed the biggest salary by $300,000, and the median did not care at all, because I didn't affect the middle. I only affected the biggest number. The middle completely unaffected. Okay, in terms of the median, I could go even more. I could type in a much bigger number. Median doesn't care. All right, the median just does not care about that. So a big outlier or a really tiny outlier, not going to affect the median at all. That's why we like the median when there are outliers in our data. When we think, we're doing something where we think, ooh, there could be outliers in this data just naturally, like in salaries, you say, okay, maybe I'll use the mean for some things, but let's also do the median so I can get a better idea possibly of what's going on. Right? If there's a situation where there aren't any outliers, you'll get means and medians that are pretty close together. And then, in terms of statistics, using the mean is actually easier than the median. And so that's why we often will stick with the mean, because it's actually easier to use that going forward. The median, not as nice. All right? There you go. So think that over, play around yourself with it, use this app. And then try to do something very similar with part 5. You're going to use the data that we gathered in class from the Google form, I've posted that already on Blackboard. I posted it already on Lumen. I'm going to send out an email pointing exactly where it is, so just check your email and I'll send it in the email too. All right, and I'll see you Tuesday.